Good morning, everyone. Welcome back to MAC1140. So in previous session, I introduced exponential function and log function, and today we continue with exponential and log, and we will be learning how to solve exponential function and log function. So I'll try to split up the video into two parts. The first part I introduce how to solve exponential function, and the second part is about log function. These two function and equation is very hard. In order to solve exponential equation, there's some strategy, a very generic strategy, general approach of how to solve exponential equation. However, when you solve any equation, any equation is very flexible. You know, you can use any method. You can use whatever you can think of with. You know, it could be changing variable. It could be using formula. You know, any property, anything. Okay. So the example I'm giving you today is just give you an idea of what exponential look like and how we approach to solving exponential equation. Okay, so let's jump to the first part, exponential equation. Okay, you already so familiar to polynomial equation, radical equation. It's just like you set f(x) equal to 0, then the function that you can convert to equation easily. Okay, so let me introduce you the first approach, the one you already learned in college algebra. We use a property to solve exponential equation. We call the equivalence property. And equivalent property says that if we have a to the x equal a to the y, then this is equivalent to x equal y. Okay, this one we already learned in college algebra. As long as we have the same base, then we can set the exponent equal to each other. Okay, I can give you a very quick example of this one. Of course, on the test or on the assignment, I'm not going to give you the very straightforward one. You know, I give you like a problem that have like the same base already. You just need to set exponent equal to each other. I'm not going to give you like that. That is college algebra. I'm going to give you something that require you to think logically, require you to think more than just set up the exponent equal to each other. For example, I can give you something like this. For example, like 2 to the 16 raised to x is equal to 16 raised to 2 to the x. Okay, so you see that the base over here is 2, the base over here is 16, but the exponent is a power number. The exponent over here is 16 raised to x, and over here exponent is 2 to x. But if in order to do this, you see 2 and 16 are kind of related to each other. We can convert it to the same base easily. Okay, you can convert it to the same base easily. 16 is let me see. So 2 to the 16 to the x, and 16 is what? 16 is 2 to the 4, right? 2 to the 4. So I can write 2 to the 4 everything raised to the 2x. Okay. And I can also write it as 2. Let me this is I just keep it for time being. You know, we're not touching anything yet. So this 2 to the 4 is to the 2x can mean 2 to the 4 times 2x, right? to the 4 times 2x, right? And 16 is what? 16. Now I can convert it because it's now the same base already. I can set it up the exponent equal to each other, so I can write it 16x equal 4 times 2 to the x, because the base is the same already. But in order to solve this exponential equation, you see that originally we have an exponential equation, we convert it somewhere, so we try to simplify it so that we have a very smaller exponential equation, and this exponential equation hadn't got the same base yet, so we have to keep doing that. We have to keep converting so that they have the same base. So 16 again, 16 is 2 to the 4 times x, right? 2 to the 4 raised to x, and 4 is 2 square, right, times 2 to the x, right? Okay, 4 2 square times 2 to the x. 4 is 2 square. I just rewrite 4 as 2 square. And now what? I'm going to apply all the formula, exponential formula we already learned when, you know, the first time you introduce to exponential formula when you in intermediate algebra, and in college algebra you learn those formula again. A to the x, a to the n raised to the m will be a to the m times n. Those formula you have to memorize. So a to the n times raised to the m will be a to the n times m. Okay, so this has become 2 to the 4x. Okay, and this will become what? 2a to the x times a to the y will be a to the x plus y. So they become 2 to the 2 plus x. Okay, and now what? We have the same base again. Now I can set up the exponent equal to each other. So we have 4x equal 2 plus x. Okay, so we have linear equation, so we have 3x equal 2, x equal 2 over 3. There you go. So what's the difference between the example I have now and the example of using equivalence property you have in college algebra? In college algebra, it's very simple, right? They sometimes give you the exponential equation that had the same base already. You just need to set up the exponent to each other. But in pre-calculus, you have to do something else. You have to do more things before you can set up equal to each other. Before you can set up an exponent equal to each other. Okay. For example, in this case, in the example right here. All right. So that is the first example of equivalence property. Let me see. I can give you another one. Let me go through all the method first. So in each method I'm going to give you example, then if I have time I'll give you more example on certain method. Okay, so that's the first approach of how to solve exponential equation. The second approach is use log. How come we can use log when you solve exponential equation? Remember, log function and exponential function they are inverse of each other. Okay, so they kind of related to each other. You look at that graph, you see that one is going up and the other one is kind of reflected over the line y equal x. Okay, so they kind of related to each other. Because they're related to each other, we can use log to solve exponential equation easily. Okay, for example, in this case, let me give you a very simple example. First, the one you already learned in college algebra. For example, you have 5 to the x equal to 16. Okay, you look at the base on the left hand side of base 5 over 16. You know, 16 I can convert the base to 2 to the 4. But the thing is that the base is different. If the base is different, you see the equivalence property we cannot be applied. You know, and we cannot convert it to that so that they have the same base. And we could find over here 2. There's no way we can convert it. So we have to use log. Okay, so we have to take log both sides. So use log, I mean taking log both sides. Okay, and you can take a natural log or a log of any base you want. Okay, whatever you want. So over here you see that the base is 5, so I'm going to take log base 5 both sides. You can take a natural log. Okay, Okay, log base 5 of 5 give you 1, remember? Log base 5 of 5 give you 1, what about the formula we already learned? So this is give you x equal to log base 5 16. Done. Okay, very quick, right? But if you can okay, you can take log base 10, you can take any log, both sides. Okay, but because over here we have log 5, so I'm going to take log base 5. You can take log base 16 if you want to. This is not a big matter. You know, sometimes the final answer look kind of a little bit different from each other, but when you put into calculator, give you the same answer. Okay, so it doesn't matter what kind of log you take. Okay, so that's the first example of second approach. Let me give you another one. How about this? How about this? Suppose 50 over 1 plus e to the negative x equal 4. You see, this is exponential equation that relate to e number. So every time it relate to e number, you think about natural log. Okay, think about natural log. So before we can start it, let's see how we're gonna, because it's in a fractional form. So we don't want to be in the fractional form. So I multiply both sides by 1 plus e to the negative x. So give you 50 times 4 1 plus e to the negative x. You know, all the algebraic process and all the algebraic operation. You know, I'm not gonna go ahead and repeat it. Okay, because you in pre-calculus already. It means what most students over here want to major in engineering. And remember, my background in engineering. Okay. My background engineer, I really know what you have to go through. So I just want to equip you guys with whatever I have to help you. Okay, so I want you guys to be better. So I'm not gonna go through some basic like kindergarten step like I multiply both sides by 1 as you cross them out. So that step is kindergarten, so I'm not gonna do it over here. When I say multiply both sides by 1 e to the negative x, you know what you have to do. Okay, so afterward, so you multiply, you distribute it. Why I have to distribute? Because when you distribute, it give you a 4 number. See, when you have a 4, you can subtract both sides by 4, give you 4 plus e to negative 46 equal 4 to negative x. Then you divide both sides by 4, 46 divided by 4, so you have negative e to negative x, so 46 divided by 4 give you what? 16, 14. So right now your to the negative x equal to 14. Now I'm gonna take natural log both sides because really everything you can take log base 3 also, it doesn't matter. But I mean, why not using natural log? Because this is e number, right? So I'm gonna check natural log x equal ln 14. When I say take log both sides, I mean any log, because you already learn natural log is actually log base e. But they're not gonna write like this. Nobody write like this. You write like this, ln. Okay. And log base 10 is log only. Okay, they don't write like this. They write like this. No. Okay. Log base 10 is LOG. Okay. Let's finish the problem over here. So ln x or ln e to the x will give you negative x, because ln e is 1. ln 14, well, you can put it into calculator, but it may give you a very decimal number, so you don't want it. So you have and it's totally makes sense, because just think about it, you have negative, you block it over here, give you positive, we reach 14. It will be 14 plus 1 is 15, right? Right? You do it with 14, 15. So 50 divided by 4. Look like the answer is not satisfied. Look like this is the extraneous one. Let me check one more time, okay? Let's check when we have any careless mistake or not. So 54 50 minus 4 is 46. 46 divided by 4. Oh, 46 divided by 4 is not 14. It's 11.5, sorry. It's 11.5. Okay. So 11.5. So it's 11. ln 11.5. ln 11.5. ln 11.5. Okay, so answer will be x equal to negative ln 11.5. And you can plug it back and check, you know. You can plug it back and check over here. So it will be 11.5 plus 1, right? 12.5, so 15. 50 divided by the 4. Alright, so this is good. It's not extraneous. Okay, I'm sorry for this careless mistake right here. Alright, so that is the another typical example of how to use log both sides. Okay. I've got so many things, so many different there's so many different form of exponential equation. You need to be exposed to those by doing a lot of problem. Okay. I can give you another one. Let me see. As I say, I think 2 examples is good to introduce this method. So I think I'm going to jump to the third method. Okay. Okay. The third method of solving exponential equation is a factoring method. It means what? It means that you look at a problem, you have to see if you can factor right away. Okay, if you can factor right away, you can use the zero product property. You can use zero product property. For example, in this case, example, what if I have something like this? 4x to the third e to the negative 3x minus 3x to the 4 e to the negative 3x. So this exponential equation, they contain 2 terms, and both 2 terms, they have e to the negative 3x in common. They also have x to the third in common, because the x to the 4 is inside x to the 4, it has x to the third power. Okay, so I can factor them out. Alright, so what I have left is 4 minus x, right? Minus 3x equals 0. Okay, everybody knows how to factor, so I'm not going to go through this in detail. So you see that after you factor, we have the product form. You can apply zero product property. Equal to 0, or 4 negative 3 equal to 0. The second one is easy to solve, so x equal to 4 over 3. Okay, and the third one, you see that this is zero product property one more time if you go ahead and apply that. So this one, I can split them into 2 cases, so x to the third equal to 0 and e to the negative 3x equal to 0. This is give you x equal to 0, or x to the third equal to 0. You take cube root both sides, give you x equal to 0. E to the negative 3x equals 0. E to the negative 3x equals 0. Just think about it. You think you can do this problem? You can solve this? If you take ln both sides, you take ln of 0. ln of 0 doesn't work, right? I told you, log, the argument always greater than 0, because if you take log of 0, it doesn't work. I already checked for you when I did the lecture. Just look at that. Look at that. ln of 0. ln 0 don't work. You see that? So this is no solution here. So my final answers will be x equal to 0 and this. Okay, so that's the way you factoring. You use factoring method. Actually, when you do the factoring, you know, inside that solution, inside that equation, you can apply anything. Sometimes you have to name variable, sometimes you have to use equivalence property, anything. You know, factoring method is just the problem. You look at it right away, you know that you can factor. Okay. Let me give you another one. Something like this. I try to give you something interesting, you know. If it is too easy, then it's not pre-calculus anymore, you know. Let me see. Let's see. Okay. Okay. Example 2. What I highlight this? You have x squared 10 to the x minus x 10 to the x equal 2 10 to the x. Well, we have 3 terms. I think I'm going to move everything to the left hand side because you see that I see the common already. So x squared 10 to the x minus x 10 to the x minus 2 times 10 to the x. You see that? When you move everything to the left hand side, you see something in common, you can factor 10 to the x out. So you have x squared minus x minus 2 equal to 0. And now you can apply 0 by 10 to the x equal to 0. X squared minus x minus 2 equals 0. 10 to the x equal to 0. Does not work, right? Because if you check a log base log of 0, which is doesn't work, so there's no solution here. So all you have is this. And this one you can factor one more time, so which is to give you x minus 2, x plus 1 equal to 0. And this is give you x equal 2, x equal negative 1. Okay, then you have 2 solutions easily. Alright, by factoring. Okay. On the last method, is naming another variable. Actually, you see that for any equation you learn so far, you learn how to solve so far, naming variable is one of the methods. Because when you name variable, you kind of simplify a complicated equation to a simpler equation. Okay, for example, what if I like that is, so e to the 4x plus 4e to the 2x minus 21. Alright, so how we name variable here? You see that e to the 4x and e to the 2x is kind of related to each other because e to the 4x is nothing but e to the 2x raised to the second power. Right? Plus. Okay. Now you see e to the 2x in common between this and this. And if you name variable, let you name t equal to e to the 2x. Then your equation become what? T squared plus 4t minus 21. After naming the variable, I convert a very complicated problem to a quadratic which everybody know how to solve. Right? And now what? We just factor. Good as good. Okay, then you see over here t plus 7 equals 0, t minus 2 equal to 0. This is give you t equal to negative 7, t equal to 3. t equal to 7, which is if you plug now, because we need to solve for x and we don't solve for t. Okay, so we're not gonna stop over here, so we plug it in, e to the 2x equal -7. You think about how we're gonna solve this. You take ln both sides, and you have to take ln of -7, which is never work, so this is no solution. All you have to do is this t, so e to the 2x equal 3, right? And you take ln both sides, which is e to the 2x, ln both sides, so which is 2x equal, 2x equal ln 3, then x equal to ln 3 over 2. Right? Okay. So when you name another variable, you must be able to see the pattern. You must be able to see the similarity. Okay, you name it so that it makes simpler. Okay, let me give you another example of naming variable. Let me see we have any other. Okay. Okay, it's kind of too prime, right? I think I'm gonna just here you go. I think this is better. All right. Let's see we have any problem here for you to do naming variable or not. Okay, right here. Very interesting, guys. Very interesting. Some of them is kind of hard. I mean, so many equations is hard. In my opinion, the equation could be very hard, but of course I'm not going to give you something too hard. Don't worry too much. Okay. How about this? Okay. Example 2. Some of them require you to do syntactic division. You know, I'm sorry. I try to find the one that really help you. Okay, let's do this. This is very interesting problem here. Let me make it bigger. Let's work on this together, okay? Because none of this I have figured out yet. But we just work together. Okay, so 8 raised to x minus 3 over x plus 2. Okay, plus 2 raised to x minus 3 over x plus 2 equal 2 raised to 3x plus 1 over x plus 2 minus 2. Okay, interesting problem. How are we going to solve this? How are we going to solve this? You have x minus 3, x plus 2 is in common. We have 3x plus 1 that is different. So this is minus. So let me see. If I move everything to the left hand side, this is should I do 1 over here? So it become plus, so this become, I can bring it up as 2 to the third power. Alright, maybe that's one of the strategy. 2 to the third power, which is it'll give you something like this. Alright, and I move everything to the right hand side. So we give 2 3x plus 1 over x plus 2 plus 2 equals 0. Right? Okay. So let me see. X minus 3. Let me see if we can convert anything over here, because 3x plus 1x over 2. We try to bring it to x minus 3, x plus 2, so that we can name variable in that case. But let me see, we can do that. We have to use some scratch paper here. Let me see, I can have some scratch paper to work on that or not. Okay. So we want to bring 3x plus 1 over x plus 2 to x minus 3 over x plus 2. At the bottom is good, so we're not going to touch anything. So over here we're going to have x minus 3 x plus 2. I can convert it to plus 2x plus 4, right? See, I can split up like that so that we have x minus 3. And what we have, x minus 3. Look at that. This is this is what we want. We want to bring it to this, right? Look at that. 3x I can split up into x and 2x, right? Negative 4x, 1 I can split up into negative 3 and 4, right? So it become what? Look. And now I can split it up. So x minus 3 over x plus 2 plus 2x plus 4 over x plus 2, right? And this is what we need already. X plus 2, and I factor them out. You have 2x plus 2 over x plus 2, which is cancelled. So you have x plus 3 over x plus 2 plus 2. Right? So I'm gonna write it as 3x minus 3 over x plus 2. I'm not touching anything over here, so I just rewrite it. But over here I can write it as 2x plus 3 x minus 3, I'm sorry, x minus 3 over x plus 2 plus 2. Right? Plus 2 equals 0. Interesting problem. We see something in common. We see something in pattern, right? So right now we can have 3x minus 3 x plus 2 plus 2x minus 3 x plus 2 minus 2 raised to the second power times 2x minus 3 x plus 2 x plus 2 plus 2 equals 0. Okay, because this one is remember the proper x to the m times x plus times x to the m plus n. So I can split up x to the m times x to the n is x to the m plus n. So x to the m plus n will be x to the m times x to the n. You see the old exponential formula you have to memorize. You cannot solve, you cannot be good at solving an exponential equation by just look at the formula. Every time you look at the formula, it doesn't work. Okay, and now what do we have? We have this in common. So let t equal 2 raised to the x minus 3 over x plus 2. Then my equation become t to the third power plus t minus, and that's what? Minus 4t plus 3 equals 0. Plus 2 equals 0. And now become t to the third power minus 3t plus 2 equals 0. See, I convert a very hard problem to a simple one, to the third degree. You know, you can use the rational zero to find the zero of this solution, which is the rational zero would be 2, right? Or 2 over 1, plus minus, or negative 2. Either 2 or negative 2, right? Either 2 or negative 2. So if you use rational zero and you use syntactic division, you're able to solve for that. Right? I don't know if I mess up anything over here during the process, but I don't think so. You know. So let me see. So the solution over here will be what? The zero over here will be 2, right? So 2 will be 2 to the 8 is the 2 to the 8. 2 to the third power is 8. 6. 6. So it will be maybe negative 2. Negative 2 work, right? So t will be equal to negative 2. Look at that. Negative 2 to the third power is negative 8. Negative 2 times 6. Negative 2 plus 6. So this is t equal to, one of the t is negative 2. And you have to use syntactic division or long division, whatever you want. So you're going to have, I'm going to do syntactic division. So you have 1, 0, negative 3, and 2. So you drop them down. So 1, negative 2, add them up, give you negative 2. 2 and 4, I give you 1, negative 2 equal to 0. So you have t plus 2, okay, t squared minus 2t plus 1 equal to 0. Okay, so you already split it up. So t plus 2 equals 0. T squared minus 2t plus 1 equals 0. So which is equal to t equal negative 2. We already see that using the rational zero theorem. You know, we already learned that. This is give you t minus 1 equals square equal to 0, which is t equal 1. Okay, but we haven't solved the x yet. We need to solve the x. So you plug that in. So you have negative 2. So you have negative 2 equal to x minus 3 over x plus 2. Now, can you take ln both sides? No, there's no solution here because it's negative. So all you have is this: 1 equal to x minus 3 over x plus 2. Okay, I'll take ln2 both sides. I'll take log base 2 both sides. I'm sorry, not ln. So I take log base 2. Log base 2 of 1 is 0. So you have x minus 3 over x plus 2. Log base 2. Right. So you mean what? It means that we don't have any solution here. So you have log base 2. I'm sorry, log base 2 of 2. I think I missed a log base 2 of 2 raised to x minus 3 x plus 2. So you have log base 2, which you have x minus 3 is equal to over x plus 2. So you have x minus 3 equal to 0, x equal to 3. Alright. Sorry, I mean, careless mistake there. I take log base 2, so log base 2 of the whole thing. So log base 2 of 2x minus 3 over x plus 2. So then your answer, x equal to 3. Okay. So you see that this problem is harder. Okay, but it's still the same method. Okay, still the same approach. All right. Let me see. I can give you some more. So this is all for a method I want to introduce, a very general approach to how to solve exponential equation. Let me see. I can give you a couple more examples of solving exponential equation or not. And let's see. Okay, let's see. Okay. Right. Don't worry, I'm not gonna give you the hard one, you know. But I mean, we always want to have some fun, right? Something interesting, you know. How about this? I don't want to deal with anything with log yet, because sometimes in exponential equation you split it and give you a log function, a log equation, which is we're gonna do in the second part of the I mean another video. What I mean, that's so not in this video. But let me see. I can give you another example. Something interesting, okay? Something interesting. Let's do this. Okay. I want you to solve 9 raised to x squared plus x minus 1 minus 10 times 3x squared plus x minus 2 plus 1 equals 0. Alright, so what do you see over here? What do you see over here? What you see is that this is look like in a pattern, right? Look like they have something similar right here, x squared plus x minus 1 and x squared plus x minus 2. So look at this. If I can write this x squared plus x minus 1, right? Then they have something really similar. So I have 9x squared plus x and 3x squared plus x minus 1. So this is kind of similar to this, right? And 9 I can split as 3 squared. X squared plus x minus 1 minus 10 times 3 x squared plus x minus 1 times 3 to the negative 1, right? Using the exponential formula. Plus 1 equals 0. And now I can write 3x squared plus x minus 1 raised to the second power minus 10 3 to negative 1 will be 1 over 3, so it will be 10 over 3 times 3 x squared plus x minus 1 plus 1 equals 0. Some students ask me that, can we cancel 3 or no? Of course not. Of course not. You know, this is the base. This is 3 to the first one. We cannot cancel. Okay. And now I can then variable let t equal 3x squared plus x minus 1. So they become t squared minus 10 over 3 times t plus 1 equals 0. So it's just what it become. This has become a quadratic, right? So you have 3t squared minus 10t plus 3 equals 0. Right? Did I miss anything? 10 to 3. Okay. Did I miss anything? I think I missed something, right? So 9 is 3 squared. I think I missed something. So over here, so 3 to negative will be negative 3. So yes, so it will be 3 over here, 3 over here. Yes. So look like it's good. Look like it's good. So now I'm gonna factor them out. Let's see if we can factor this. So we have 3t, and over here will be 3t, right? And so you have negative 1, negative 3 equals 0. Okay, then you're gonna have 3t minus 1 equals 0, or t minus 3 equals 0. So you have t equal to 1/3 and t equal to 3. And now we gotta go back and plug them in order to get the x. So t equal to 1/3, so 1 over 3 equal 3 x squared plus x minus 1. Okay, 1/3 I can rewrite as 3 to the negative 1, right, equal to 3x squared plus x minus 1. You see that this is exponential equation that had the same base. So I can set up the exponent equal to each other. So x squared plus x minus 1 equal negative 1, which is x squared plus x equals 0, which is x plus 1 equals 0. Then it becomes x equal 0, x equal negative 1. Okay, so that is just for the first t. For the second t equal 3. So you have 3 equal 3x squared plus x minus 1. The base over here is 3. The exponent is 1. The same way I can set up x squared plus x minus 1 equal 1. Right. So to give you x squared plus x minus 2 equals 0. Okay, can we factor this? No, we can't. So we have to use can we factor this? Negative 2, negative 1, negative 2. I think we can, right? I think we can. So so it will become x minus 1 x plus 2. Yes, we can factor this. Right. So to give you x minus 1 equal to 0, x plus 2 equals 0. So you will have x equal 1, x equal negative 2. So totally, how many solutions we have? We have 1, 2, 3, 4. Okay. 4 solutions. All right. So I mean, it's your job to go ahead and plug them back. But I mean, some equation, I mean, it takes time to do that. So it's your responsibility to go back and plug, and check if this extraneous solution or not. But I think this is all solution. I can go back and plug them and check. I mean, you have calculator, you can do that easily. All right. So I think that's all for the video today for solving exponential equation. If you have any question, let me know. Again, you have to be exposed to many exponential equation. How are we gonna do that? You have to do many problems. Okay, then you get used to it. Okay. All right. So please watch the go through that again. If you don't get anything, just send me a Canvas message. Okay, and I'll see you next time on how to solve log equation. Bye bye.